Hi, everyone. Thank you for joining me. I'm Bahija Humphrey. I'm the CEO of the Data Science Alliance. And I really want to thank you all for joining us for the first data skills workshop, where we have members of the community teach other members of the community. I'm going to quickly do a screen share and go through a few slides, and then I'm going to pass it over to our esteemed speaker. So let me just do a quick screen share. So did I do that right? Can you see okay. All right, so Data Science Alliance, we're a community of data lovers focused on advancing San Diego as the leader in data science. We're doing that by focusing on 3 key priorities: problem solving, that's what data science is all about. How do we solve problems? Business investment, how do we integrate more data science into existing businesses, but also how do we encourage more startups, data science startups? And then, of course, talent development. I noticed there quite a few of you are students, and so we welcome you. We want to help bridge the gap between your graduation date and your career. And how do we make sure that there's a pipeline of opportunities for you available here locally in San Diego, so that you have the option of staying here in this beautiful city and starting your career. We are a member-based nonprofit, and so I really encourage you to consider joining our organization. If you want to join, please take a look at our website. There you'll find all the different options to join as a member. And then for those of you who are interested, we also have the volunteer opportunities where you can sort of earn your way toward membership. And you'll see on the screen here, the website datasciencealliance.org. To get to the membership and the community page, you just do /community. But we also have a very extensive social media presence, thanks to our amazing interns, Kayla and Kashika, who attend UCSD, by the way. We have all the channels here for you. Please keep connected with us through those various channels. That's where you'll find all our upcoming events and kind of interesting news about what's going on in data science here in San Diego. I really encourage you to follow us. So, okay, so I don't know about you all, but I'm really excited about today's data skills. We just posted, recently we had a data visualization contest online on social media. If you're still interested, today's the last day. You can submit your entry in, find it on social media. And basically what we're asking for is people to submit their best data visualization, and you can win free membership to our organization. But also you can win bragging rights. So the deadline is today, and then we'll have our winners announced this Friday. And so this is great timing for this particular workshop because for those of you who may have missed it or are interested in participating in our next data visualization competition, or just want to up your game in data visualization, because it's truly an art. And so there are tips and tricks to get yourself to the next level. We've asked an expert to come in and talk to all of you and teach you about those tips and tricks so that you can make your data visualization sing. And so that expert, I'm very excited to announce, is Shannon Ellis. And I think some of you may know her from UCSD, but I'm going to go ahead and tell you a little bit about her before I have her take over. So Shannon Ellis is an assistant teaching professor at UCSD. Before joining the cognitive science department, she received her PhD in human genetics from the Johns Hopkins School of Medicine and was a postdoctoral fellow in the Department of Biostatistics at the Johns Hopkins Bloomberg School of Public Health. Wow. Shannon is passionate about data science, ethical data analysis, and education. One priority of her work has been working to ensure that data science education is accessible to underrepresented underrepresented populations and groups who typically have not had access to such materials, which that's totally sings to me. So I'm so glad to have someone working toward that. Okay, so let me stop this screen share. And it is my honor to introduce to you Shannon Ellis.
Thank you so much for that introduction, and thanks for having me today for this first data skills workshop. I'm super excited, and I'm glad to see, have all of you here. I can't necessarily see all of you. I'm going to go ahead and share my screen. Okay, so the plan today is to talk about the art of effective data visualization. And as Becky just said, I am a teaching professor, so this is going to work a little bit like a class. I couldn't just talk at you for an hour, and that just wouldn't work for who I am. So what this is going to be is a little bit of an introduction to some concepts, and then there will be an interactive portion at the end where I ask you all to do something and we get to share our ideas. For that end part, you just need your brain and maybe some piece of paper. If you happen to have software where you like to do data visualization, you could use that, but that won't be required. And since this is the first data skills workshop, we're going to kind of hope that everybody can take something away from this, but we're not jumping into some really technical tools yet. Okay. For those of you who haven't necessarily used I was opening the chat. If you haven't necessarily used Zoom previously, if you want to get my attention, feel free to unmute yourself or to type something in the chat. I'll keep an eye on that one. Okay, so we will jump right in to talking about the 4 parts that I'm gonna go over here. Now, 1 and 2 are going to be super quick. I'm going to generally talk about the concept and point you in the right direction if you need help figuring out what the right plot or the right graphic is for you. I'm going to introduce the fact that there is this thing called the Glamour of Graphics, but really where I'm going to focus today is on the Glamour of Graphics, how to take your figure, your graphic from accurate to effective. And then the 4th part is this idea of iteration. That's where I'm going to ask you all to iterate on a few tasks and put into practice what we talk about in section 3. All right, so jumping right in, this idea of the right plot. You have data, you want to visualize it in some way so that when you communicate it to others, when you show it to somebody else, they're able to quickly figure out what it is you're communicating, what they should do next. So this idea of the right plot is you have data, what is the best approach to then take it from a whole bunch of data in a spreadsheet, in a CSV, and make it something that really communicates your point. And in my classes, I go through all of the different types of data you could have, whether or not it's quantitative and you have a bunch of heights or a bunch of weights, or if it's categorical, like your favorite ice cream flavor, and the different typical visualizations that people will use based on the data they have. For the sake of time, I'm not going to go through all of that today, but I am going to point you in the direction of an awesome and really visually appealing resource called From Data to Viz. And it helps you figure out, given the data you have, what are possible different types of visualizations you could make. And the way it works is you specify what data you have, whether it's a single numeric variable or 2 or a bunch of categorical data. And then you go through this flow chart to figure out what possible visualizations might you want to consider given the data you have. So if you only have a single numeric variable, maybe you're considering a histogram or a density plot. And they're color-coded so that you can determine if you want to visualize distributions, you're considering this yellow part. If you want to talk about correlations, those would be the gray visualizations. And there are a whole bunch of different plot types that are covered on this website. Now, they're by no means exhaustive. There are other visualizations beyond what you see here, but this is a great place to get started if you're trying to wrap your head around what the right plot might be. So, as I said, sections 1 and 2 are going to be super quick. This is a great resource if you want to figure out what graph is most appropriate, what you might want to consider when you're trying to visualize. Once you have that in mind, I want everybody to know that there is something called the Grammar of Graphics. Now, this was a book written by Leland Wilkinson a little over 20 years ago. And it's called the Grammar of Graphics because you really can take a figure and break it down into its component parts and identify what they are. The same way you could identify the subject or the verb in a sentence. Graphics have their own underlying grammar, and understanding how those work together can really help you figure out what the best way is to visualize your information. So I'm not covering the Grammar of Graphics in any exhaustive manner, really just letting you know that resource exists. And I'm going to talk about 3 of the core components: data, aesthetics, and geometries. Okay, so here is this pyramid. And at the bottom is your data, right? That's what you're going to start with. That's what you're going to build an effective visualization on. That's what you're trying to figure out how to communicate your point effectively. I've highlighted in green the aesthetics and the geometric objects. And the idea is, once you have your data and know what it is you want to visualize, you then have to figure out what positions the values are going to take. Is each observation in your data set going to be a single point? Are you going to summarize them all in, say, a bar chart? And once you figure out how you're going to take your data, map them, figure out what's going to go on each axis or within your plotting space, you can then choose your geometry, the shape of your plot. Now, of course, there are stats, facets, coordinate systems building on top of that. But the core idea is you have your data, you figure out how you're going to map your data to your figure, and then what shape those data should take, be it a scatter plot or a bar chart or a line plot. So when you're looking at a plot, here is the first not great plot I'm going to show you today. Here we can see there's pieces. We can talk about data, what's being plotted. Here, these are data from a penguins data set. So each observation in this data set is a different penguin from Antarctica. And you then figure out what's going to go on each axis, right? You're going to map your data to the geometry. So here, bill length is on the x-axis, flipper length is on the y-axis, and we decided the geometry here is going to be a scatter plot. So you might look at this and say, okay, we see that as bill length increases, flipper length increases. Generally, but there's some groups in here, and that each point on this plot represents an individual penguin. And we can see the overall trend, and then you can start breaking it down to figure out that this is a scatter plot, what's on the X and the Y, and what data are being plotted. But typically you don't start with the plot, right? This is where most of us start. We have some data, and we're trying to decide what type of plot to make. So you usually have some information about the data when you set out to generate a visualization. Here, I'm just going to show you that you have 3 different variables. Month, then you have within that month how many tickets were received and how many tickets were processed. And if you're thinking about a sort of plot that you might use, if you're familiar with different types of plots, if you're not at this point, you might go to Data to Viz and figure out what plots would be appropriate. And you have to figure out, given this information, what plot would convey your point. Now, you would probably want some background information, and I'll get there. But this is a possible plot you could generate, right? So here we have all 3 variables plotted. On the x-axis is months. On the y-axis is the ticket volume received, or the ticket volume processed, so it's the number of tickets. Blue is received, and red is processed. But there is a lot going on here, right? We have a whole bunch of lines. We have numbers that are on top of each bar. We have a whole bunch of decimal places on the y-axis. And then you have to compare the size of the bars within each month. Alternatively, you could plot the same exact data as you see here. And here we're using a line plot rather than a grouped bar chart. And there is an informative title letting you know that you should hire 2 full-time employees because 2 employees quit in May. And there's now, we're not able to keep up with the tickets we're receiving. Process is now lower than what's received. And it's this process that I want to focus on today. That first plot I showed you was accurate. That was an accurate representation of the data. But it wasn't effective. It didn't communicate the point. You couldn't quickly see that there is this growing discrepancy between the number of tickets received as they were processed, and you had to work harder to understand. So the idea here is, how do you take a plot from simply being accurate and displaying your data to making it effective? And that is where I want to talk about this idea of the glamour of graphics. Now, this phrase is directly stolen from someone named Will Chase. He is an awesome data viz expert from out of Philadelphia, and he gave a keynote at RStudio Conf this past year titled The Glamour of Graphics. So we're going to see his ideas intermingled with mine throughout. Okay, so you could use that initial bar chart with the red and the blue next to each other, and that would be effective. So why spend the time to go from that first plot to the second one, the line plot with the blue and the gray? So there's 3 reasons I can think of here. One is that you engage more people. So when you're communicating, whether it's in a lecture hall or giving a talk over the internet, or you are sending a figure to your boss, sending it to a colleague on a group project, you want to be able to communicate your point effectively, and you can do that more quickly and with less friction if you are spending the time and engaging them with graphics that are effective. You also benefit from the aesthetic usability effect. So what this says is if you make stuff that's more aesthetically pleasing, people will perceive you as more knowledgeable. So if you and a coworker have the same background, the same skills, but you are able to effectively communicate your visualizations and effectively communicate your point in an aesthetic way, you will be perceived as more knowledgeable even if you have the same background. So it's worth spending the time to have people believe that you are more knowledgeable. And it also demonstrates respect for your audience. You don't want your audience to have to work any harder, right? You're all sitting in front of a computer screen. It's already hard enough to pay attention. We've all been remote learning or remote working for a while now. And it's up to you, the presenter, to try to do the work ahead of time out of respect for your audience so that they don't have to do the work to understand your points. All right. Any questions up to this point or any comments that anybody wants to add? Okay. So the idea here is I'm going to set out 10 ground rules for good figures. So as you're considering how to effectively communicate your point, my thought is you've already decided what type of plot you're going to use, or maybe you're between a few. And you're going to then improve on that to go from just accurate to effective. And I have 10 general rules. They're going to fall into 3 general categories. One is going to be layout. The second is going to be typography. And then the third is going to be color. And there are fields of study within each of these. So by no means is this exhaustive, but it's meant to get you a start, things to consider on every figure that you end up communicating out into the world. So the first ground rule is to include an informative title and to left align them at top left of your figure. So for each of these rules, I'm going to give you an example. On the left is generally going to be what we're trying to avoid, and then on the right will be a slight improvement. And we're going to improve this graphic that you see here through these rules. So I'm using that same penguins data set here. And I am plotting how many of each species of penguin we have in the data set. And on the left, we have a title that maybe conveys our point, but it isn't all the way left aligned. So having a title is a good thing, but it's not in this leftmost corner. And the reason we're encouraging leftmost corner is because there's been studies that have been done that is visually where individuals who read the English language, so from left to right, go first. So you want to, again, this is all about making your point as clear as possible and making it easy on the viewer. So you want to put the title where people first look when they're looking for a title. So on the right, we have a title that is all the way to the top left. And we see the title, Adelaide Penguins, most common in Antarctica.
Good boy.
The second ground rule here is to not make people tilt their head. So a lot of software, be it Excel or be it different packages in Python or in R, by default will have some bad defaults. And it's up to you to decide whether or not you want to keep the defaults or spend the time to improve upon the defaults. So lots of software are good for making data viz. I haven't found one that has perfect defaults yet. So what we're trying to avoid that you see on the left-hand side is we don't want people to have to tilt their head. Studies have been done. It takes longer for people to read it and to interpret what's going on. So try to figure out a way in your visualization to avoid people having to tilt their heads. So what we see going from the left to the right is I've taken the x-axis, the species, and made it the y, and taken what was formerly the y-axis and made it the x. So we've just tilted it 90 degrees. And now you can see each of the different penguin species in this data set without having to tilt your head. The third rule of good figures is that you should consider how to have clean lines and symmetry throughout. For this one, I'm not going to use the penguins. I'm going to use this example of a visualization from 538. And there is a lot of information being conveyed here. So the title says how Eurovision rankings would change under the new scoring system. So they're looking at 2014 and 2015, the old system versus the new system. And there are a lot of design elements here that are taken under consideration to show you a whole bunch of information without it becoming too overwhelming. One of which is the idea of alignment. So a lot of the text here is left aligned, but you don't have to, for any of these rules that I'm giving you, there are going to be exceptions, right? So if you want visually to see this and be highlighted in the center, you want to right align some of the text in your visualization. And know that center aligning can be helpful for certain titles and certain labels. Now the designer made a slight mistake here. This 2014 should have been centered where this dotted line is. But overall, you can see there are multiple axes of symmetry. So that if you were to fold on multiple places, you would see symmetry either across the entire visualization or within each of the halves of the visualization. So this, along with the use of bolding to highlight the places where countries would have had much different scores between the two systems, and having gray fall into the background, makes this very involved graphic easier to understand. So consider alignment, consider clean lines and symmetry throughout your visualization. The fourth rule is to avoid using borders. So for example, going back to our penguins here, on the left, we have a square border around our data, and on the right, that's been removed. This border on the left is a distraction. It doesn't add any information to your figure. So we want to avoid any additional cognitive load on our viewers. So we remove the border, which follows along with point 5. You want to generally remove and lighten as much as possible. So taking where we left off on the last slide, we've removed the border, but there are lots of other pieces that can be removed to make this visualization even more effective. For example, I've removed the grid lines in the background. Those don't add any additional information. I've lightened the two categories that are not the point I'm trying to make, right? I want to highlight the fact that Adelaide penguins are the most common. So I've first changed the order, moved Adelaide to the top. I've also removed the x-axis. We only have 3 bars here. You can directly label each of these, and then you don't have to visually look from the bar down to the x-axis to figure out what the number is. And I did one other thing, and now I can't remember. Oh, I removed the space between each of the categories and the first bar. So remove, lighten, make it as easy as possible on your viewer to understand what the point is that you're trying to take away. The 6th rule is that legends suck. This is one that almost every visualization software makes more difficult on the person making the visualization itself. So most software will, by default, generate some sort of legend. So what you'll see on the left-hand side, if we're looking at this plot, we can see there are some purple dots on the left and some green dots on the right, and we see there's differences between these two values. On this figure, to understand what purple means, you have to visually look up to the top left, say, oh, that's Valdez, and then look at the green and look up at the top left and say, oh, that's O'Rourke, and then you can filter that down and so you know what green and purple are. Conversely, on the right-hand side, if you label the purple directly in the same color and say purple is Valdez, you don't have to do that work to figure out what each point is. Now, this is a case where there are only 2 colors, but there will be times where you'll see lots of different colors on a single visualization, and then you'll have a very long legend, and it'll be a lot of work to try and figure out which color goes with which label. And if at all possible, it's really helpful to avoid using legends. The 7th rule is for my home chefs out there. And there's a general consensus, although there's some debate here, that when you have a recipe, you take whatever amount of garlic is in it and then just triple it. And that's the same idea for white space. A lot of people, when making visualizations and communicating things graphically, initially tend to try to make it way too busy, put way too much stuff on a single slide or a single visualization, and they need to pull back and use white space. It is effective. You don't, again, want to make this too overwhelming on your viewer. So my example here is on the left-hand side, a very busy dashboard. There are a whole bunch of different visualizations, different types of graphs, different numbers, a whole bunch of icons, a lot of colors, and you don't necessarily know where to look or what your message is supposed to be. Conversely, on the right-hand side, we have a dashboard where there is something to focus on right in the middle. And of course, there's additional information on the dashboard, but you know where you're supposed to focus first and what your message is supposed to be. So use white space like garlic. It's okay to have white space on your visualizations. With these last few, there's this idea that less is more. So it's more effective, more attractive, more impactful. Your viewer knows what to look at, doesn't get stuck trying to figure out where they're supposed to be looking while you're speaking. And it's okay to not have every inch of every graphic or every slide filled. You can still make your point. The first 7 really have to do with layout of your figures. Number 8 here is the fact that fonts matter, and you should absolutely prioritize readability. So my favorite examples of this have to do with people who maybe designed logos for their stores or storefronts without considering font. So these are just 2 examples as to why you want to prioritize readability and maybe don't want to prioritize the newest, coolest font before checking carefully. Now, fonts matter, and there are lots of options out there, especially with Google Fonts and its availability. So there is a book called Practical Typography, and it will teach you more than you maybe ever need to know about typography and that I can't cover here. So I'm going to say go there if you want to learn more. But for now, I'm going to give you these 4 safe fonts that are up at the top left. The bottom 2 here are serif fonts, which means that there are, little edges at the side, so there's flat parts on the top of the Y. The top 2 are sans serif, so without serif fonts. And these are really readable and aesthetically pleasing, great fonts to go with if you're unsure where to go. If you read Practical Typography, you'll get lots of other ideas about fonts, but I'm going to give you those 4 as safe fonts. In this presentation, I use Crete Round for my titles and the guide at the left, and then Muley for everything else. So again, lots of information in Practical Typography, but when in doubt, prioritize readability and keep it simple. Number 9, similar to me using a single bullet point in 8 to cover all of typography, is that I'm going to go through 3 general rules for how to use color effectively, knowing that I can't cover everything about color in a short presentation. Okay, so same idea, prioritize readability. Bright blue on bright green is hard to read. White on gray is very easy to read. So take a look. If you're ever straining to figure out what something says, consider whether the colors should change or maybe the font should change. And here are the 3 rules. So beyond just readability, choose intuitive colors. So on the left here, we have what's less than ideal, and on the right, we have an improvement. So for example, the reason the left is less than ideal, we in society associate certain colors with certain things and certain groups. So a forest and a lake, we associate green with forest and blue with lake. You don't want to label things counterintuitively. So rather than have blue be forest, we want green to be forest, and we want blue to be lake. Now, this doesn't mean you always have to go with the associated color. So for example, females don't always have to be pink, males don't always have to be blue. Just don't do the opposite of what people would intuit. Don't make people work harder than they need to flip what we in society have associated with the color. So don't make good red, make bad red. Also, this is one that I see probably broken the most of all of the rules here. So consistency is key. If you have multiple visualizations, if you're making a report for your team at work, if you use blue for China in one visualization, it shouldn't later then be red, right? People should be able to keep the same color consistently throughout whatever it is you're presenting. So if you use red for the UK in one visualization and blue for China, China should be blue later on and Germany should have a new color. So again, all of this is to make it easier on your viewer. And as a visualizer of data, gray might be your best friend. And this is something that is counterintuitive to a lot of people as they get started out. So on the left, we have what we often call a spaghetti chart. There's a whole bunch of line graphs right on top of each other, all different colors, and you're not sure where to focus. However, if your company wants to see their price over time relative to all the competitors, maybe you make the lines for your competitors thinner and you make them gray to fall into the background and make yours highlighted and a little thicker so that you can quickly see which line it is you're supposed to focus on. And this goes beyond line charts. Gray is great for data visualization, and you'll probably notice as you look at visualizations out in the world just how much gray is used. Okay, I lied. There are 3 rules, but there's also a bonus. This bonus is to remind everybody that gradients are for continuous numbers. So if you have a whole bunch of heights or weights, you might want to consider using a light blue to a dark blue. But if you have distinct categories like we have here, we have 4 different individuals. Each individual should get a distinct color. So gradients for continuous variables, distinct colors for categorical. All right, there is a question. Tay, go ahead. You can type it in there or feel free to unmute yourself.
Yeah, I'll just unmute myself.
Great.
So I was creating a visualization for one of my projects, and on the x-axis, I had like a range of age groups, and on my y-axis, it was like the share of, I guess, like proportion of how much population consists, whatever.
Mm-hmm.
And I was wondering how I should use my gradients. So should the gradients, represent the age group? So should younger groups have lighter gradient, or should groups that take up more proportion have darker gradient, I guess?
Okay, so this would then be a bar chart where your x-axis would be in order, your bins. So that's where like order would make, and this is for everybody else, I'm sure this is what you had. You would have bins in order of age group. So you would want to make sure from left to right that you had the youngest age group to the most oldest age group. And on the y-axis, you would have the number of people in each bin. And this is where I would say you might not need color at all. You might need them all to be gray. If there were one bin you were trying to highlight, right? If you wanted to say 40% of our participants fell within the age range of 25 to 35, that would be the only one that maybe you would change the color of. And this is something I see from students a lot. The defaults will be to like make it a rainbow, and those colors don't mean anything, right? The red doesn't mean anything different than the green. So this might be one where I would choose a single color for all of them, unless you have something to highlight.
I see, thank you.
Yeah, no problem. Did I say something other than age when I meant to say age? There's a comment with age question mark. If I said something else, I meant to be talking about age bins. Okay. Okay, anything else up to this point? All right, so the last ground rule is that it's important to keep in mind that your design choices convey tone. So if we return to the idea of fonts and add on the fact that fonts matter not just for readability, but also because they convey tone, right? On the left side and the right side, we have the exact same words, "You'll always be mine," but the loopy font on the left conveys a more whimsical message of "You'll always be mine" than the like blood dripping right-hand side that is maybe a little more sinister. So fonts are one way to convey tone. The second is that the overall design of your visualizations convey a tone. So here on the right, we have an infographic. The title says Iraq deaths on the decline, talking about the Iraq war and how deaths are decreasing over time. You could take the same exact information, the same data, the same plots, change the colors, orientation, and title, and convey a completely different message. So by turning the histogram by 180 degrees, changing it to red, the color of blood, and changing the title to Iraq's bloody toll, the message of this infographic completely changes. And it's up to the designer to, one, display the data accurately, but two, to keep in mind that how you make your design choices alters the message that people are going to get. All right. So these are the 10 ground rules that I think people should consider every time they're trying to create an effective visualization. And now, these are ground rules. Rules can be broken at any point in time, but you want to make sure you're doing them consciously and not just because it is the default in whatever software you're using. So use these to first, anytime you create a visualization, first think, what's your point? Make that the title, make that the headline of your graph. If you want people to take a certain action after doing that, put that at the top. If you want to make sure people get one certain point, make that your headline, and then use that to determine how you're going to emphasize things in your chart. Which chart type are you going to choose? Which data are you going to include? What aren't you going to include? What colors should you use? How should you highlight? You know, thicker lines, thinner lines, bolder lines, and then what annotations? Do you need text on it to really make sure the viewer understands what you're talking about? And then you can, after you prove the thing it is that you're saying, you can then explain it further with description or legends or keys or source information. So coming back to this example that I motivated right before I started talking about the glamour of graphics, I wanted to just highlight a few of the aspects that I've been talking about that is used on this visualization. So for example, there's an informative title that tells you what you should go do after you see this, right? Approve the hire of 2 full-time employees, makes it very clear. And then the proof is below, where what's being plotted on each axis is clear. Now you can see there's a rule broken here, right? Number of tickets is tilted and you have to tilt your head to read it. And that can be a decision that you make here, that it is more effective to include a y-axis that is tilted than to include it anywhere else on the plot. There's white background, there's garlicky white space. It's not very busy. You know where to focus your attention, and you focus your attention on the data directly. So the lines are labeled directly. You don't have to use a legend. Color is used effectively. You quickly see that processed is falling behind received. The text and labels are removed at places where it would be distracting, right? Where the blue and the gray are right on top of each other, the numbers don't matter nearly as much as over here where they start to be further from one another. So there are no round points at these plots and at this points in the plot, and there is no text labeling. Annotations help guide the viewer's focus. We have this vertical line to show you where the split happened and then text to explain what's going on. So the question here is, what tool did you use to create the line graph? So this is actually from a book called Storytelling with Data, and every single visualization in that book is created in Excel. And one of the author, Nussbaumer's points is that you can make effective visualizations regardless of software. So a lot of people in the data science world look down on Excel, and she explicitly, and this was training she developed while she was working at Google, was like, hey, you can do really great things across lots of software, so we don't need to look down on Excel. And she actually shares all of the data and visualizations publicly available. So if you wanted to check out any of these, just Google Storytelling with Data. That's a great question. All right, other questions at this point?
Is this the final recommendation of how to visualize that story, or is there going to be an improvement on that as well?
So there's not going to be improvement on this one, but there's always more than one way, and we're going to go through this process of iteration through it on the next few examples, but this is the last I'm going to say of this one, but there are for sure changes you could make to this one.
I think what I'm after is, I think in general right now, the whole talk goes very much towards the design of these charts. I think a very important topic in general in data visualization is also pre-processing of the data. So
For sure.
You know, the step where you think about maybe how you can modify the data, mix match it with other things just before you even pick the geometry. So I think in this case, I was thinking, you know, maybe you could also show the cumulative number of open tickets. So you kind of like see a growing line instead of having 2 lines that almost look like constant after a certain point. to kind of like emphasize that, you know, the number of tickets are growing now and we have to take action.
I think that's a great suggestion. So if you're really trying to show that you're like not able to keep up, you would see that cumulative total grow each month, saying like, hey, we really can't keep up, rather than just how many you received each month and how many you processed. I like that suggestion a lot. As for the pre-processing, super important. And the last thing you want to do is display data that aren't what you intended to display or what you think they are. So the idea of data wrangling, I think, is likely a data skills workshop that will exist in the future. And so I think that point is really, really important.
Yeah, thank you.
Other thoughts here? Okay, so this is where I'm gonna, in a few seconds, give you all a task to do and see your thoughts. And the idea here is this is an iterative process, right? Like the first draft you make of a visualization is probably not going to be your final draft, and it's gonna take more time than you intend. Will Chase, who I mentioned earlier, was asked in his talk, like, how long does it take you to create a visualization that he winds up, you know, using for a client? And he said the shortest would be like 2 to 4 hours, but it can go for days, right? Like this design process is not a quick one, even though it sometimes feels like it should be. So what I'm going to ask everybody to do is to, using this idea I've borrowed from Allison Hill, who's an awesome educator at our studio, is to take a SAD plot and make it better. So the idea is there are two axes, ugly and pretty, right? You could have an ugly plot all the way to the most beautiful plot you've ever seen. And there's also the other axis of crap to useful, right? And we're aiming to make things that are not only aesthetically pleasing, that are also useful and informative. And so to motivate this, I'm using Allison's example and then gonna leave you all to do some of this on your own. She had this visualization she used to use in her slides where she was trying to convey the fact that even if autism is constant in a population, if more people are accessing services, it's going to look like there are more individuals with autism. So this was her first attempt at that. And she looked at this and said, there's a lot going on, there's a lot of colors, how can I improve it? And her second crack at it was to go from time 1 to time 2, showing that something's increasing, something else is staying constant. And then you have to look down here and there's pie charts and they have some highlighting going on. And she sat back and was like, okay, the first attempt was at least useful. We could convey the point. It wasn't the most aesthetically pleasing. The second one, even though it was an improvement, an attempted improvement, it actually was more confusing and more towards the crap. So she said, what can I do to aim here? And so she started iterating on this idea. And so she first decided to use this idea of a stacked bar chart to look at prevalence being constant, but those accessing services increasing. And this was her first chart, went through and said, okay, maybe I want different colors. Okay, let's remove all of the junk we don't need. Let's directly label so that we don't need a legend. And then let's start adding in annotations so that we draw people's eyes to the important pieces. We see this increase, add in the annotation explaining to viewers what's going on. And that was her first one. Okay, not the most beautiful, not the most useful that it could be, but it's an improvement. And she continued to iterate to say, okay, we want individuals to be there. Maybe we can't directly label. We need a legend in this case. And maybe those colors aren't actually adding anything in. And so she continued to iterate on this and has a few different versions that are all improvements on her first go around. So for this, I'm going to give you all a few minutes to take a SAD plot and make it better. So we're aiming for useful and pretty. And I'm going to give you a starting point. I'm pulling 2 data sets from the publicly available data that San Diego City puts out. This first is a policing data set, and the rows are each a police stop. The third column here is disability, where most police stops have no perceived disability from the police officer's viewpoint, but a handful have some impairments that were recorded by the police officers. And this is the first SAD plot of these data, where you can see that the vast majority of stops do not have a perceived disability. So we're focusing in just on those stops that did. And here is a pie chart that is accurate, but maybe not the most effective. So this is the first option for people to suggest improvements. The second one is San Diego expenditures data. So how much money did San Diego spend in different budget lines over time? So we have the amount spent, the year, the fiscal year, the department from which it was spent, and then some additional information. So from this, I made a stacked bar chart where I'm highlighting a few specific departments and then how much money is spent with each department on the y-axis and then the fiscal year along the x-axis. And so this is what I'm going to leave you all with. And the source of the data are here. If you happen to be a whiz, have software you want to start making this in real quick, you could grab it. For everybody else, I want you to either brainstorm or jot down on a pen and paper or use a tool I'm going to show you in a second to aim for how do we make these useful and pretty, and do that considering the plot type, the layout, the typography, and the color. The way we're going to do this is there is a link, bit.ly/DSA_viz. And this is going to take you to a Padlet. If you have never used Padlet before, you don't need an account. You should be able to post anonymously. If you do have an account, your name will show up. And I was hoping we could all start improving, right? So you could, if you press the plus, add in text. So suggestions on how you would improve this plot or this plot, or if you want to choose your own adventure and start improving on one plot that you've been working on, you could show your before and afters. You can add text, or if you scroll down within this, you can upload a figure. If you do the 3 dots, you can also take a picture of something. You can draw and doodle on screen your own ideas. So you might have a redesign of this. And I'm going to give everybody a few minutes to just start suggesting ideas, maybe work on it. And you can vote, upvote, or downvote if you like somebody else's idea or if you have a similar idea. The last one here is just resources. This is Data to Viz, the talk from Will Chase that I mentioned, the ground rules that I discussed, and then a whole bunch of helpful links in case they're helpful later. So I am going to leave this slide up for a few minutes so that everybody can get that link. And feel free to start working on this, and I'll keep an eye on the chat if anybody has questions. And then we'll discuss possible solutions at the end and take a look at what you all think. Thanks, Kayla. That makes a lot of sense too. The link is also in the chat. Yes, that would be possible. I should add that to both. I'll add it to both places. So here's the first data set. Here's the second. I'll also add it to the Padlet. I should have thought of that. Thanks for the comment. No, I haven't given you a ton of time. I'll give everybody another few seconds and then we'll see what everybody's ideas are. All right, so just trying to bring it back and then talk about possible solutions. So this policing data, we started with this pie chart. So there was a suggestion for a bar chart, descending order based on count, which I really like that idea. Want to use different colors for each disability category. Cleaner font, perhaps in the sans serif family, so something that's just very clean lines would make that more appealing. Oh, I like that we got a drawing here, have different tints of green. So you have none to convey how many had none. Oh, I like this idea here. So see the suggestion here that you'd see the breakdown within those that do have some sort of perceived disability. Best if you use a bar chart, x-axis on the left, y-axis on the bottom. Too many colors, so clean that up, color code, and highlight just one portion if that's your thing you want to highlight. And then question was, could we use gradient since it's disabilities? And I'll look at the solution that I have, and we can talk about that question then. On the expenditures, maybe a line chart with different line for each department. Get a good title. Show stack bars as percentages of expenditures, right? So if you want to be able to compare between each of them, you want proportions rather than counts. So that's a great suggestion if you wanted to keep a bar chart. Better font. Great question. What is the person trying to convey? And that is, as you, the designer, would get to decide. And then maybe some interactivity, which is something I didn't get into at all. And then we have people posting their choose your own adventures, which I'm excited to check. Okay, so we have the start and then the improvement. Oh, that's looking good. And then another suggestion for a plot that might be helpful. Okay, so I love those ideas. I iterated on this a little bit and have some suggestions, but they are by no means exhaustive or the only solution. And they incorporate a lot of what y'all suggested. So instead of this pie chart, maybe we use a bar chart, but we want to be able to see the relative differences between groups. So as was suggested by people in the on the Padlet, rotating it so that you can see the differences in sizes, sorting it in order of most common to least common, avoid needing to rotate and tilt your head, remove all of the junk on the plot you don't need, give it an informative title, add an informative x-axis label, add source information, and then, as was suggested, maybe just highlight the one that's most important to you to convey to your audience. So if your point is mental health condition, the most common impairment identified during police stops, then maybe you make that one stand out amongst all of the others. So this would be a place where you probably wouldn't want a gradient because there's different categories, even though one of your variables is quantitative. On the other one, we started with a stacked bar chart. As was suggested, I decided to go with a line plot based on the different departments. And then these are really helpful for showing trends over time. Removed a bunch of the junk in the background, gave X and Y axis labels, cleaned up the tick marks so that they were actually the fiscal year, then started changing color to be what we intuit. Used gray for the things we weren't highlighting, used direct labeling so we didn't need a legend, and then added an informative title, increased the thickness of the lines to highlight, made the y-axis more intuitive. Before it was 4 times 10 to the 8th, changed that to 400 million, and added the data source annotation. You can, of course, always iterate further. Maybe you add color to your title, use bold font for highlighting. Or there's always more than one way to do it. If the red and blue is confusing, maybe you just make those that are public safety related blue together. So there's always more than one approach that works. And if y'all spend time and think this is fun the way I do and have other better solutions, feel free to add them to the Padlet after. But the idea is here, we're taking accurate data and then making it more effectively communicated. All right, so with that, we talked about briefly the right plot and the Glamour of Graphics, spent most of the time on the Glamour of Graphics, and then started talking about this process of iteration. All the links I've included throughout are also here at the end, and I have places for additional inspiration if you want to see other awesome visualizations. And because I'm a professor, I'm going to give you homework. Find a plot in the wild, try to critique it, try to recreate it, and try to improve it. And you can use these additional inspiration sources. A lot of them share their data, so you could start working with it. These slides are not yet up on my website because they like answers were there and I wanted y'all to not be stymied by my thoughts. So I'll put them up on my website after. And if you do the homework or have better suggestions on the Padlet than what I had, feel free to put them on the Padlet or feel free to email me or tweet them at me. All right, with that, I'm happy to answer any questions. I know we are close to time. So if you're keeping an eye on 1 p.m., you're about there. Thank you, everybody, for having me today, and I'll take any questions if y'all have any. So there's a question from Elijah about a specific laptop you would recommend for data science. At UCSD, they do have a resource, and I don't want to get it wrong for where it is, but I will add that to the Padlet after. I know that the majority of data science students at UCSD do use Macs, but that's by no means the only machine you need or could use. So I'm going to share that resource and then just share that the majority, I think it's certainly the most popular, was to have a MacBook, but you could do your major on any machine. I use a MacBook Pro, if that's helpful, and have for years. Tool I use to visualize data. Yeah, I use lots of different tools. I use R a lot. I use Python sometimes. I use Tableau sometimes. I tend not to use Excel just because I'm faster on these other tools, but it just kind of goes back and forth based on what I'm feeling that day and what I want to visualize and what I'm most comfortable in. All right, I'll hang out for a few additional minutes in case anybody has further questions. But since we're at time, I want to thank everybody. Thank you, Data Science Alliance. Check out their website and see whether or not you are interested in becoming a member or volunteering. And I really appreciate your time. Thank you, everybody. Power BI, great question. So I don't use it, but it is used pretty heavily in industry. You'll certainly see it in design-based internships. And so it's worth your while to learn if that's the direction you want to go in. Oops. All right, Bahij, unless otherwise, I will end us out. Have a great day, everybody.
Thank you.
Thank y'all.